Alright, good morning. Today we're starting a new chapter. Chapter 10. It's a big whole chapter and pretty much new ideas for you. Probably some of you guys haven't seen most of the material here, but heard it probably. Like square roots, we use it we a lot. But what all this is called basically are radicals. And there is one section in the end of this chapter called complex numbers, so we're going to take a look at that as well, but the main subject here is called radicals. Okay, so what's radical about them? You will see next. Okay, first section is about finding nth. N is a number, will be provided to you, like sec2 we call it square root, 3 cube root, or 4th, 5th, 6th, 7th, you can go all the way, root of numbers or expressions, what we are going to take a look at in 10.1. Start with the very basic things you already heard here in math. We already used this many times. For example, I say find square root of 36. What do I mean by square root? The word square root means find square root of 36. It's actually a puzzle question. I want you to think a number, multiply it by itself, and it makes 36. Okay? Square root means find a number, multiply by itself, it's gonna make that given number. So what number when square equals 36? And your response is it 2? 2 times 2 is 4. No, too short. Is it 9? 9 times 9 is 81. It's kind of keep a multiplication table. You need to know your multiplication table facts and keep trying until you hit the magic number. 7, 7, 49. No. Oh, 6, 6. What is 6 times 6? 36, right? So you found square root of 36, but only one of them. 6 is square root of 36 because it multiplies itself and makes 36, but most of them you didn't know there was another one about minus 6. What happens if you multiply minus 6 by minus 6? Take a calculator and try. That also makes 36. So the first news of the morning is square root of numbers can be double, positive and negative. And we always think the positive side usually when I ask, but think of negative as well. There are two. Alright, let's take more examples and check your multiplication facts. What is square root of 25? Anyone? No, it's not 5. No. It's not 5 only. Yeah. Negative 5 and positive 5. Did I say just single? No, look, it's plural. Find square roots of 25. It's not just 5, but also minus 5, negative 5. Because when you multiply negative 5 by negative 5, it makes it. Now you got your lesson. What are square roots of 49?
7 and negative 7.
Yes, negative 7 and 7. There is only one number whose square root is not double, which is 0 has square root as itself single. It doesn't have a plus or minus. Oh, there are numbers whose square root is like this one, minus 9, square root of minus 9. Square roots of minus 9 are maybe. Doesn't work. We don't have none. Why? How come? Isn't square root of 9 minus 3 or positive 3? No, when I multiply either positive 3 or minus 3 itself, I get positive 9 and positive 9 all the time. This is saying negative 9. Another news, another lesson we got today is negative numbers do not have square roots. Negative numbers are bad. They don't work with square roots. Okay? Now, isn't the sentence too long? I can't write this down all the time. Identify, find out the square roots of number 81. Find out the square roots of number 125. It's too long. So what math people did is, can we just put one symbol and it will say the whole entire long sentence here? For example, can I say find square root of 36 shortly? Is there a notation for it? Yes, there is a notation. When I put this notation, that means, this means find square root of whatever the number comes in underneath it. For example, 36. Again, what is this notation means? Find square root of this bunch, which is, you're gonna tell me, 6. Oh, but we figured out there are two, plus or minus. Which one do I mean? If we don't see any sign in front, we always mean the positive one. Again, if this symbol doesn't have any sign in front, we always mean positive option. Essential, very important, guys. This is one of the common mistakes. When I ask what is square root 36, people always give me plus minus 6, plus or minus. Wrong. If you don't see any sign, it's plus. So when do we pick the minus option then? If you see a minus option in front, then you put me minus 6. Okay? So that's what it says here. Square root of any number inserted here is always positive option. When is it negative? If you see the negative sign in front, then we mean the negative one. And again, 0, square root of 0 is always 0, no matter what sign you have in front. Plus or minus, still 0. Is this clear? Right, let's practice. What is this? These are all 2 seconds questions, if you've been listening to me. What is root 9? No, you haven't been listening to me.
Just 3.
This is just positive 3. Why?
Because it's
Yeah, we don't have any sign in front. That means it's positive option. Okay? So again, this is not saying just find square roots of 9. This is only saying find positive square root of 9. This says positive one. How about this?
negative 6.
This says find negative square root of 36, which is negative 6. Okay? How about this? Yeah, this says find positive square root of 49, but it's negative 49. Is there a number, positive number, multiplying itself into negative 49? Can you find such a number, multiply itself and it's negative? No. This is none. Square root of negative numbers do not exist. It's none. So how do we answer this question then? Let me show you how you... First, if you get a number result, yes, it is a real number is what you're gonna do, and then you put down that number, check. But if, like number 3, it has no result, it's not a real number, and you're done actually, because there is no answer here. Alright, when we go to the last section, what is the last section of this chapter? Complex numbers. We will learn how to evaluate minus 49 there. It's gonna be not a real number, it's gonna be a complex number, like we will call it 7i. You will see what I means there. This is called a complex number. You need to wait for a while for that. So far in this section and the following 6 sections, whenever you see negative numbers under square root, it doesn't exist. Doesn't exist in real life. Are we good so far? Let me know if you miss a spot or something. I can explain. Again, this is a new chapter, new beginning. So let's make everything solid before going forward. Okay? How about if you have a fraction? It's a combination of 2 numbers. How do you find their square roots?
Square root of each one.
Yeah. you find, oh, I lost my pen. You find square root of each part, top and bottom, and put it into ratio. That's it. Oh, come on. So what is square root of 36? But it's still same positive. I see positive sign in front of square root. It's 6. So I'm going to mark 6 there. So 36 will make 6. How about square root of 25? 5. So it's positive 6/5. If you have a minus, it's going to be minus 6/5. Unless you see nothing, it's always positive. Unless you see a minus sign, it's always positive. Okay? So let's try this on our answer box. So again, it's a real number. We found it as 6/5. Alright, proceeding further. About with decimals. You need to think decimals now. Just ignore 0.49. Just think 49. What would be the answer for if it was only whole number 49? 7. So try adding zeros to it. Like to make 0.49, probably try 0.7. And literally you need to take a calculator and multiply 0.7 by 0.7 here. 7 times 7 is 49. Points make 0.49. Okay. So yeah, these are gonna be decimals, but you get the idea what the 10th digit will be from the 10th and hundreds. 49. It's 7. It's 0.7. Okay.
It'll be 0.07.
If it's 0.07 and multiplied by 0.07, how many digits we have here? 1, 2, and 1, 2. Then you will have 4 digits after the dot. 1, 2, 3, 4. 49. I'm sorry, 49 here. So when you multiply 2 digits after the dot, you get 4 digits after the dot, and you get an extra zeros. So you literally take a calculator and multiply if you wish. 0.07 times 0.07. Yeah, it's frozen. There we go. 0.07 times you see 0049. So if you're not unsure, always check with a calculator. 0.7 times 0.7 is 0.49. So decimals are tricky. I mean, there is an easy way to get it in the first, but just go with trial and error on that case. Alright, do we always have square roots in this section? No. We may go higher. Okay? So, like nth root means you multiply that number n times itself. Sometimes 3 times itself, sometimes 4 times, 5 times, 6 times. And you get a brand new number. And b is called nth root of a. If you multiply b n times itself and obtain a. Such as, here's an example. 2 is a square root. We already seen that in the first 2 slides. Square root means you multiply by itself and get 4. Third root means you multiply a number 3 times itself. 2, 2, 2. How many times? Look, this is 3 times. And get a number 8. Then 2 is a third root of 8. We sometimes use the word cube root instead of third root. Okay? 2 is a fourth root of 16 because you multiply 2 4 times itself. Look, 4 times itself and get 16. 2 to the fourth is 16. So we say Fourth root of 16 is 2. This means you multiply a number 4 times itself, it makes 16. Alright, the symbol changes a little bit. You see the little n here? For square root, we didn't denote 2. Look, there is actually a magic invisible 2 there here. But we skip writing it for square roots. Everywhere you can make them visible. It's called index. This is called index. This is what tells me how many times this number should be multiplied to 36 over 20 to make 36 over 25. How many times this number is multiplied to make 36, okay? This tells me how many repetition happens. So when I see now 3 or n, I know that the result, this 3 will be multiplied that many times. Again, that number outside is called index, and the number inside called radicand. These are the words I will be using. Index is the number outside n, such as the index of this thing is 4. That means use number multiplies itself 4 times to make 16. And this number is called radicand. When this number index becomes 3, index 3 has a special name. It's called cube root. What was index 2 called? Index 2 called? Come on.
Square root.
Yeah. Square root. Only index 2 and index 3 have special titles. We don't have anything for 4th index or 5th index, okay? But you can make one. What do you want to call 4th index? Quad root? Quad as in 4? I don't know. 5th root is penta root? I don't know. Okay. Yeah. We are happy with square root and cube root. Let's not invent new names. Alright. Now, a few details. Couple details. As we said, if you don't see any sign in front of any radical notation, it's always positive. It goes with positive if this n is an even number. So if this n is an even number, they need to tell us what sign in front. If they don't tell anything, it's positive. But if n is an odd number, the sign of the result goes with the sign of the inside. For example, I know cube root of 8 is 2. Because when I multiply 2 3 times itself, 2 makes 8. How do I know it's minus 2? Where did I get the minus 1? I didn't have any minus here. Now that minus comes from inside. Alright, now you'll be shocked. I told you, you cannot get square root of minus 16. If you have a negative number, this is not a real number. Not real. Right? But now you're seeing that somebody evaluated this as a number and they put minus 2. How come? I thought if we have a negative sign inside, it's always not real. No. The case not real is true if index is 2, 4, 6, 8. What kind of numbers are these? Even. So here is the story. Here is the lesson. If the index is even and the number inside is negative, then we do not have a real answer solution. You will just pick not real and go to the next question. But if the index is 3, 5, 7, 9, what kind of numbers are these? What are these? Odd. If they are odd, the result exists. It's a real number and you can compute it. Did you get the lesson? Odd numbers are fine. Odd numbers work with negatives. Even indexes don't work with negative numbers. Okay? Alright? Okay, going back. For square root 0, you don't have to worry about odd or even. It's always 0. So any kind of index has 0 in it, it's always 0. So here is some list of powers of numbers in case you didn't know. I don't want you to go sit down memorize these, but at least know the cubes of some basic numbers, like 5 cube is 125. Okay? 4 cube is 64. 4 times 4 times 4 is 64. 3 times 3 times 4 is 27. Do you need to know these? I mean, at least know these 3 or maybe 4. And these are getting harder. At least know these 2 maybe. But it's hard to keep these in mind, the rest. So I'm not pushing you to know all these powers, but it's good if you are familiar with them, alright? It will be helpful. For example, what is 5th index of 3125? What do I mean by this? What number multiplies itself 5 times? So you're gonna find a number here. It multiplies itself 5 times and it becomes 3125. Which one does it on the list? 5. 5 multiplies itself 5 times, becomes that. Alright. How about cube root of 64? Yeah, that's 4. It means 4 raised to the power 3 is 64. 4 multiplies itself 3 times and makes 64. Okay, this is fun. How about 4th index of negative 81? What number multiplies 4 times itself to 81? You guys are amazing. You're doing great. Agree? No, that wasn't a compliment. Because you made a major mistake. Yeah, what did I tell you here? I've been talking myself all the time. If inside is negative, be aware. Negative numbers, alert, alert, alert. You need to check the index if you see a negative number. If you have an even index, this is negative. Even index, no result, not a real number. Okay, let's play another one. Come on, yeah. How about now? What number multiplies itself 5 times? A pick number from the table, multiplies itself 5 times and you get 243. Find 243 on the table. And a number multiplies itself 5 times to it. Are you sure? Are you sure it's not a real number? Maybe it's not real. Yeah, this time it's negative 3 because this is odd. You don't have to worry about negative inside. Why is it negative? Odd indexes just gets this out here. And then you compute 5th root of 243 from the table, which is 5th root of 243. A number multiplies 5 times itself is 3. That number is 3. Okay? You're getting there. Let's practice more. It's just same practice. What do you think? Square root minus 64, real number or not? Let's do it on the screen. Number 7. You will tell me the answers. I don't know. Wait, it's number 6. Is negative 64 computable or not? Not, because this is an even index negative number inside. How about this? Oh, it's negative. Is or is not? Is? You sure? Yeah, we don't care the negatives outside. We care about the negatives inside. This is positive 64 inside is computable. How about cube root of negative 64? Negative number inside, so it's not, right?
No, it is.
It is because odd index. Odd index 64 is square root positive is positive. Odd index is always fine. Odd indexes are beautiful. They compute everything, negative or positive. So let's check. Yep, it checked out. Now compute negative 64. Anyone? Let's do this quickly. Negative 64. Root 64. What number multiplies to 64 but the negative option? Negative 8. What number multiplies itself 3 times to negative 64? Multiply number 3 times itself, it's gonna make 64. Negative.
4.
Negative 4. What number multiplies itself to positive 64? Positive 4. What number multiplies itself to 64? 8. Not 3 times, just double. This is twice. 8 times 8 is 64. Isn't this the same? No, it's not. It's not the same as this one. What number multiplies itself 3 times to 64, but you're gonna take negative of it later. So first answer this part. Multiply a number 3 times itself to 64 and choose a negative of it. Negative 4. About this one? No, we're done? Okay. Alright, I'm curious. I'm not done. How about this? Do you agree? Is the answer negative 4?
Would you technically not be able, would it be not real just because you wouldn't be able to get?
No, it's real number you will get because it's odd index. Odd index are always gonna give you answer. You will find something. Is it negative 4 or positive 4?
I think it might be positive.
Alright, how do we do this? Start inside out first. Take a look at this part. Compute this first. This part. Ignore minus. Compute this. What number multiplies itself 3 times and makes minus 64? What number is that? So you're gonna pick a number. I believe it's 4. Will multiply itself and will make minus 64. No, not positive 4 will make it, right? If it's positive, it's gonna make positive 64. It has to be negative 4 to make it negative 64. Agree? So this part is negative 4. This part. But we have an extra negative outside combining with this, correct? So it's gonna make positive 4. Okay? How about now? Look at this first. Always focus on this. This minus is not our concern. Compute this. What number multiplies itself 4 times to a negative 256? This is an even index. Even index can never multiply into a negative. Not real. You're not even checking the outside side. Okay? Not real. Alright, I think you're ready. We're just gonna do some more random questions and then start things with x's. Look at this, x and y's. One more thing. cube root of 1 over 8 means you take cube root of 1. What number multiplies itself to 1 3 times?
1,
1. What number multiplies itself to 8 3 times?
2.
You're done. That's it. Okay. How about now? What's that?
Negative 4 over 3.
Yes. We first take negative sign. You can take negative sign out if it's odd. So we have the negative sign secured first. And then think of what number multiplies itself to 3 times to 64. It's 4. What number multiplies itself 3 times to 81? Hey, hold on. That's wrong. It's not 81. I didn't mean that. I mean 243. What number multiplies itself 3 times to 243?
3.
No, it's not 3.
No.
3 times 3 times 3 is 27. It's short. You need to get 249. It's 6. 6 times 6 times 6 is... No, I picked the wrong one again. Because it's not making, right? 36 times 6 is 180, 216. Okay, let's make this 216. You're right. Now you're right. Okay, 64 over 216 is my question. Alright. Now, what is different in the following 4 questions? Quite different than the previous 9 questions we solved. Variables inside. Variables. They are no longer asking me what is cube root of 81. What is cube root of 27? They have some weird stuff inside. Alright, here is the story you're gonna approach these questions. If you wanna consider this symbol, relate these symbols into a real life concept, what would these look like? What are these look like? This one. In real life, what do you wanna call this thing? What object does it look like?
Root symbol.
What?
Square root symbol.
In real life. If you go take this symbol to your grandma, ask, oh grandma, what does this look like? She will say, square root.
Square root symbol.
What is she? She's an engineer or PhD degree? Okay. I'm just trying to see your response. What would you put it at assignment and go with it? But okay, I will go with my idea. It looks like a roof, right? This looks like a roof. And what is this extra piece here? It's like wires, barbed wires. Like it's like somebody wants you to capture under this roof and won't let you go. This is kinda they put mines, traps in there so you can't escape, right? So do you know such a place in life? And this guy looks like a guard waiting. If you approach to this barbed wire, electric fence, they're gonna shoot you. What does this look like? Where is this place?
Go.
It's not my country.
That's in jail.
It's a
Jail.
jail. Yeah, it's like a prison. Okay, it's like a prison. This guy, of course, what do you call this guy? Prisoner. But there's a difference from prisoner to prisoner, right? There are rich prisoners and there are poor guys. Alright? Losers. Unfortunately, yeah, sorry. Yeah. So there are bosses of the prison. They have a lot of money going on. So sometimes they break the prison. They come out of the prison. They have big lawyers. Oh, come on, this is life. I'm just trying to put it into real life, okay? So So the money each guy has is listed here. This is how powerful this bad guy is. He has $3. And the guard here waiting for these guys, keeping them secure from society, is here. This is the guard. And he is asking for $3. Give me $3, I will let you go. Alright?
So if it's equal, it cancels the square root.
Yeah, that's what I'm trying to show. If you want to break the prison, come out of a radical, you need to match what they demand. They demand 3 and I have 3. But this is how you pay off. You pay off by division. You divide this one, the guard, with the bailout money. This is your bailout. Bail. This is what how much you have in your pocket, and this is what guard wants. If it matches, you divide them, and you have nothing left. 1, right? So you are set free. You're out, but you are broke. You have no power left. Okay? Now I want to show you another example. How about this prisoner? Is this guy rich? Is this guy rich? Does it have money? Yes, he has $6. They want $3. So he wants to break prison, right? He wants to post the bail, okay? That's the right term. So they post the bail, and how much he has money left though? Look, always, no, I give you the wrong order. You take the number in to the top. What guard wants is to the bottom. I give you the wrong order here. This is not guard. This is what you have, your money, yours, and this is what guard wants. So it is 6/3. Divide them to, you still have some money left over, some power left over. Okay? So this is the math we are gonna always do. Divide what you have in the power with what index wants. Okay, that's the story. However, so you know n and n matches. This is n over n, and it's a to the first is a. That's how they got this result. But what's going on here? Alright, this is the story. This is what's going on here. Sometimes your number can be negative. I want to explain that here. What's the difference of this and that? Here is the mistake, guys. The idea I gave you, bail money and guard wants, division needs to be adjustment. This is the adjustment you're gonna make. You think, oh, this is, you have $2 and they want 2. 2/2 is, this is what you have, red. Black is what they demand, it's 1. You say the answer is 2. The answer is 2. And here you do the same math. -2, 2/2. You cancel these. It's 1, and -2 raised to the 1 is -2. This is correct. This is false. But wait a minute, I just applied the scenario I gave you. I just paid off, bribed the guard, and came out as it is. No, this is false because of this fact. What happens if you guys multiply -2 by -2? What is -2 times -2? 4. This thing is 4. And what is square root of 4? This is a positive option. It's positive too. The correct answer is still positive. It's not negative. Okay? So the idea I gave you, paying off the guard, is incorrect. It needs adjustment. What is the adjustment? This is the adjustment you're gonna make. Whenever you take somebody out from an even index, you need to put your answer in absolute value. If it turns out to be a negative number, you need to fix it into positive number. So the method I gave you was correct, but everything should be going on in between walls. Public shouldn't see it. You're paying off, bribing somebody, you should keep it secure between walls and get the result positive. Okay?
Hypothetically speaking, though, would you technically be able to do that because the index was even?
Yeah, I mean, we only do that for even indexes. Odd indexes, you don't have to worry. For odd index, if this is a cube, minus 2 cube, you just do this. You don't need walls, you don't need absolute values, just minus 2. Because isn't minus 2 cube minus 8 and cube root of minus 8 is minus 2? So the answer is always correct. Okay? So for odd indexes, don't you worry. Again, that's what this says here. All the story I told you is compacted here. If you have an odd index, you don't need absolute value around your answer. But if you have even index like 2, 4, 6, 8, and this guy has some money, 2, 4, 6, 8, and you divide and get computer, put your answer between two bars. If it's a number, compute that bars of that number, absolute value of that number should be computed. But if it's a variable, you cannot compute it, put it in the answer with absolute value. Coming to this question now. I do my prison guard computation, right? It's y 3 over 3, correct? Which is y to the first. The answer is y. Question is, do I need an absolute value or not? You tell me. Do I need an absolute value? No, because, no, take it back. No, why? It's odd. Got it? Let's do it. This is just y done. Alright, x squared. This is even index. I divide one into another and I'm saying my answer is x. And I will check my answer. I'm surprised. How come it's not x? Why? What's wrong? Because this is even. Whenever I have an even index, I don't know what kind of x we have. It may be negative number. How do I know this x is positive? It may be there is a minus 5 behind x. So this answer is minus 5, impossible. So I need an absolute value if I have an even index. Okay? Put absolute values when you see even index. So I see even index here, I will put absolute values already. I see odd, no absolute value. So before starting your question, check out the index. If it is even, put absolute values into your result before even you start. Okay? So let's fix this now. Put, how do you make absolute value here? Alright, thanks. Oops. There you go. Now we're good. Alright. Anything changes here? No. Look. It's odd. I don't need an absolute value. I will just do the prison guard relation, which is 3 over, divide this number by that. 3 divided by 3, it's 1. It's just p plus q raised to the 1. It's just p plus q. And this one, I will do it right here. Before anything else, I start with an absolute value, guys, because it's even. And then I take prison guard deal between these two. 2 and 2 divide each other, 2 over 2. Prison guard issue again, 8 over 2. Okay, and we do simplification. So what is 2 over 2? What is 8 over 2? This is z, not 2, okay? Alright, this is acceptable answer. However, if inside an absolute value, if there are terms with even powers, you can take them out of absolute value. Such as if I have x squared under an absolute value, it comes out, because x squared is always positive, square of something is always positive. They don't need an absolute value. You can move it up outside absolute value, and absolute value will have nothing in it, so it just dissolves, it just goes away. It's true only if you have even powers. So I have a feeling one of these guys can break absolute value prison. Next time you have a different kind of prison here, z to the 4th can come out because it has even index. This is even. So this guy doesn't have a bar around it, only w. This is odd, w still needs it. I will put the absolute value around w only, not z to the 4th. So kind of z to the 4th comes out and w is on the top, still has it. Yeah, does it make sense? So I just shrink this absolute value to cover only this guy, not z to the 4th. It doesn't need it because it's always positive thing. There is no possibility of being negative. Only w needs it because w can be negative, so we need to fix it. Alright? So this thing is gonna be fraction, absolute value on the top, w inside it. Z is safe because it has even index. What if z had a cube? If z had a cube, you couldn't let him go. Z cube will be inside as well if it was cube. Only even numbers can break absolute value. Alright? So you're learning a lot of stuff here. Maybe most of this stuff is new to you. Did you know that even index powers can come out absolute value? Maybe not. Because they are always positive, they don't need an absolute value. Okay, okay, we're gonna do these things with numbers now. Just check what type index do you have and tell me if we need an absolute value or not. Do we need an absolute value? Yes or no? Do we need an absolute value? This is even. Yes, we shall need an absolute value on our answer. But how do you compute the result? You have a prisoner who is very rich. He has $10 or $10 million, but the guard wants all of it, 10, all 10. So they will 10 will be divided by 10, and guess what it drops to? 10 over 10 is 1. So it is just absolute value minus 444. Are we gonna leave our answer like this? If inside is a variable, you can't take care of this. This is your answer. If it's a variable answer, you leave it alone. But this is a number. You guys are perfect, can perfectly compute absolute value of numbers. What is absolute value of a negative number?
Positive.
Positive. So the result is positive 444. Make sense? This one. Alright, do this one, somebody. First response will get credit. What's that? Positive 84. One answer is positive 84. Is he right? I don't know. Any other answers? Anything else? Anybody else? Try negative 84. Maybe that's the right answer. No, that was a trap. It's wrong. It's positive 84. How? What is the validation? First, even. This is even. I need an absolute value to start with. Then we do the guard prisoner exchange. How? Prisoner offers $6, guard wants $6, they even out, cancel to 1. So you have only minus 84 inside with an absolute value, but that's positive 84 because absolute value makes all things positive, right? That's it. Alright, this one. Do we need an absolute value? No, this is odd. We don't need. Only thing you need to do is prison guard exchange among each prisoners. This has $3, guard wants $3. This has $18, guard wants only $3, so you divide it. So this is u to the first, this is v to the sixth. 18 divided by 3 is 6. u over v to the sixth. All done. No absolute value required. How many prisoners do you count here? 4. Good answer. 1, 2, 3, 4. All of them individually wanna break the prison, wanna pay off the guard. But I don't see a guard. What is the guard? Where is the guard? How much the guard wants? How much? It's 2. If you don't see nothing, it's 2. Okay? So does 4 have what guard wants? Does it have it? Although you don't see it, it does. 4 is 2 squared. So he has what he wants. Divide 2 by 2. And 4 comes out as 2 to the first, which is 2. But before you even move this number here, I missed one important thing. What did I miss? What? Yeah, because of the even index, I need to put all these inmates, once they are free, still in absolute value for extra caution. Because it's even. I need to make things positive. And then see who can break this absolute value prison. Next, a to the 6. He has $6, guard wants $2. What is how much he has left in his pocket when he's out? A to the third, 3. Because 6 over 2 is 3. It's not most people make this mistake. They take off 2 from 6 and make 4. 6 minus 2 is 4. He thinks $4 left. No, we divide always, not subtraction. How about 8 and 2? 4 and 2? Okay, which one of these inmates, still 4, this time it's a low security prison. This is a low security prison from a hard security. This is absolute value. Which one can break out? Which one? Which ones can break out? Break.
B to the fourth and
Only B to the fourth,
C to the second.
C to the second. How about A cube? This is odd. How about numbers? Yes, numbers can break prison as long as they are positive. If they are negative, flip the positive and break the prison. So 2, B and C can come out as 2, B to the fourth, C squared. Unfortunately, A cube, it doesn't have even power. It's stuck. This is the answer. Does it make sense? I hope so. Okay. Can we quickly do this one as well? 64. Raise 6 to the 4 into power so he has money to break the prison or not. 64 is power of 2 what? What power of 2? 2, 2, 2, 2, 2. How many times 2? What?
8. 8 times 8 is 64, right?
8 times 8 is 64, but not 2 to the 8.
Oh, that's right.
That's too much. 2 to the 6. Come on. It needs to be 6 so he can break prison, right? Alright, this one is already raised to power, so let them break the prison. So First, do we need an absolute value?
Mhm.
Yes, even index we do. 2 to the 6 is 2. 6 and 6 gone. 24 divided by 4 is
C4.
4. And y to the 12 is 2. By the way, we made a mistake. On this question, we didn't need an absolute value. Why? Because we didn't read the statement. If in the statement it says everybody x, y are positive, you don't have to worry about absolute values. Okay? So actually here as well, this is wrong answer. We gave a wrong answer. If you try this in ConnectMath, it's wrong because it says A is positive. If you cube it 3 times, it's positive. You don't need an absolute value around that. I should have read this before. How about 16? Is 16 positive as well? Yeah, we don't have an absolute value anyways, so we were safe here. In 15, did we need an absolute value? Yes, because it doesn't say positive numbers. It doesn't say positive in 15 and anything before, but 16, 17, and 18 has positive numbers, so don't worry about putting absolute values. This is the answer. Okay? So you're saved, no absolute value required.
Isn't STO 206